Okay, yes, Marissa.
Yeah, there's a lot I cannot find on the internet, especially if it is the download. Okay, where does it talk about monoatomic anions? Because I only saw monoatomic ions.
Okay.
Where does it talk about monoatomic?
What's the answer, Todd? Okay. So you want to give her a definition real quick?
Huh?
No?
Who, me?
Yeah.
Oh, sorry.
You don't know it off the top of your head yet?
Anion?
It's got a negative charge.
Anion.
Anions have a negative charge.
So it's just a monoatomic with a negative charge?
That's correct.
It didn't say that.
Thomas, you got a question?
What is a molecule from the formula that has a different formula unit?
A molecular formula?
I'm sorry. Can we be quiet? I just refuse to raise my voice today, okay? I've got to do something tonight where I can't afford to be hoarse. And I'm not going to try to talk over you, okay? Thomas, try again, please.
What is a molecule formula and how is it different from a formula unit?
What is a molecular formula? How is it different from a formula unit? Okay? Well, for a molecule, the molecular formula is the formula unit. But the formula unit is different for other kinds of substances. For example, with ionic compounds, the formula unit is like the simplest whole number ratio of the ions in the formula. Structural formulas actually show you the way that the atoms are bonded together.
But what about the first? Like, what does it mean by what is the formula unit?
I just defined what a formula unit was. That for a molecule or a molecular substance, the molecular formula is the formula unit. It tells you actually how many atoms there are in the formula. But for an ionic compound, the formula unit is the simplest whole number ratio of the ions in that substance. And for an empirical formula is for any substance the simplest whole number ratio.
So what is the formula you say, like the ionic?
A formula unit for a molecular substance is a representation that tells you exactly how many atoms there are in a molecule. So C4H10 is a molecular formula. It tells you exactly how many carbons and hydrogens there are in the formula. And that is also the formula unit for that, because that's a molecular formula. That is the formula unit for a molecule. An empirical formula would be C2H5, simplest whole number ratio. Okay? A structural formula would be, you can have a complete structural formula. You could have a condensed structural formula. Or even the skeletal formula, the structural formula. Okay? Because that tells you how the elements are actually bonded together. Okay? Yes? What is a molecular dipole? It's a polar molecule. A polar molecule. You know, like water is a bent molecule, and when we figure out the polarity of the bonds, we find out the bonds are polar, so this is going to be a polar molecule. So this end of the molecule is partially negative, this end of the molecule is partially positive, so these are the poles. It's called a dipole. Well, it's called a dipole because there's two poles. Does that make sense? Like a magnet has two poles. I don't know why it's that dipole, but that's what it is. All right, Thomas, you have another question?
Number 49 is like, what is the hybridization of the carbons in the carbon-based board?
All right, without actually looking at number 49, what, this? It's asking for what the hybridization of these are?
Yeah.
All these are sp3s. All these carbons are sp3s.
So, but if you got like pentane, it can be sp3.
Yeah, pentane is a straight chain carbon, so it would be just one more carbon. For carbons, if you have nothing but 4 single bonds on an atom, that has to be sp3, because single bonds are sigma bonds, and sigma bonds have to come from hybridized orbitals. Well, if there are 4 hybridized orbitals for all those bonds right there, the only hybridization you know of that has 4 hybridized orbitals is sp3. As long as I have nothing but single bonds on something, that has to be sp3. The reason is that each of these single bonds are all sigma bonds. They're straight on a line between the nuclei of the 2 atoms. Okay? All sigma bonds come from hybridized orbitals. And the only hybridization that has 4 hybridized orbitals is an sp3. But you can also have an sp3 from something like this, because lone pairs also come from hybridized orbitals. So this is also sp3. And you can have this. This is sp3, because you've got nothing but single bonds and lone pairs. Well, all those have to come from hybridized orbitals. You can also have this. That's sp3, because single bonds and lone pairs come from hybridized orbitals. That means there are 4 hybridized orbitals, because I got 3 lone pairs and 1 single bond. So that's also an sp3. Okay?
So on number 24, it says on each single bond, an atom shares blank of its electrons in the bond for a total of blank electrons in the bond.
Say it slowly again, please.
On each single bond, an atom shares blank of its electrons in the bond.
One of its electrons. Go ahead. 2 electrons in the bond. Correct. So every time you have a single bond, like this is a single bond between these 2 carbons right here, each carbon started out with 1 electron that it's going to share, right? So in this bond, this carbon brought 1 electron, this carbon brought 1 electron, and they share, so the bond has 2.
So you put like half, it's still be right.
Okay. Well, that goes back to just understanding why we do all that sharing arrangement stuff we did in this unit. Okay. Yes, Amber? What is the question you have?
How can you share this? We have a molecular compound from the
Okay. If you have a combination of any non-metals, okay, that have these subscript numbers on them, then that's going to be a molecular formula. Say I have PCl3, okay. Is this a metal or non-metal? Well, you got a periodic table, look it up. Is it a non-metal? Are we sure? Huh? If you're not sure, get out your test references. Okay? It's not helping you nearly as much if I tell you. It helps you a whole lot more if you look it up. It's a non-metal. How about this one? So if they're bonded together, what kind of bond do they make? Covalent. And as long as if it's a covalent bond and we have a specific number of atoms in the formula, like this has a specific number 3 and a specific number 1, that has to be a molecule. Okay? You can have covalent bonds like, let's see, let me do it this way, SiO2, and then I put an X outside. Well, what that is that's the formula. That's a covalent bond because it's 2 nonmetals, but goes on and on and on and on. It makes a big crystal. So that wouldn't be a molecule because of that X right there. We don't know how many of those units there are in there. But this tells you there's a specific number of units in there. So what I mean by a specific number is this X doesn't tell you a specific number. It's a variable. Yes? Not every single one, because sometimes there are problems with the videos, but I am putting a lot of them on there. There are a lot on there already. Yes? Yes. What's number 29?
What is the difference between complete structural formulas, condensed structural formulas, and skeletal?
Okay. Well, the complete structural formula shows every bond between atoms. Okay, now let's look at that and look at this one. Now you tell me what's different between this and that. Yeah, but what does this tell you that this one doesn't? No, the number of elements are there. It doesn't show you every bond, does it? You have to kind of figure out how some of the things are bonded together. It only shows you the carbon group. This is complete, this is condensed, and this is skeletal. Okay? So what does the skeletal formula not tell you that you have to figure out for yourself? Well, yeah, I mean, you know that the carbons are implied by every corner, but what else does it not tell you? You have to know where the hydrogens are just by being able to figure it out. So any carbon that just has a single bond on it, how many hydrogens does it have? Huh? If this is a single bond on this carbon, it's got 3 more hydrogens. And this carbon here is showing 2 bonds coming from it, so it has how many hydrogens? 2. You have to figure that out. Okay? Thomas? What's the difference between hydronium and ammonium? Well, there are 2 different formulas. Hydronium is H3O plus, and ammonium is NH4 plus. Okay, the structural formula of those things, hydronium is like this, with an overall charge on the whole thing, and ammonium is like this, with a charge on the whole thing. Okay? So hydronium is this stuff here, and ammonium is this stuff here. Yeah, it's on. What is it? Page 3 of the unit handout. Okay. I want you to be able to use that to be able to explain how it is hydronium is formed, okay, and how ammonium is formed.